Forces. The types of forces are push, pull, torsion, gravitational, friction, buoyancy, magnetic, air resistance, compression, thrust, upthrust, and weight are all of the types of forces. So forces are measured in newtons, which is a symbol of that is capital N. Weight's a force, and to work out weight we do mass times gravity. So weight equals mass times gravity. Weight is measured in N newtons, mass in kilograms, and gravity in newtons per kilogram, which is 10 on Earth. So if someone weighed 52 kilograms and they were on Earth, their weight would be 520 newtons. Friction. Friction only applies when two surfaces are rubbing past each other in opposite direction. It acts against the direction of movement such as travel. Air resistance, drag is a type of friction. Density. Density is how many particles are in a set area. Floating objects are less dense than water, or they're less dense than what it's floating in. So density equals mass divided by volume. So let's say the mass is 50 grams. Volume is 10 centimeters cubed. The density would be 5 grams per centimeter cubed. Right? Per 1 centimeter cubed, sorry. Balanced / unbalanced forces. So balanced forces are when the forces in various directions are equal. The forces are equal when an object is stationary or moving at a constant speed. Unbalanced force is where one force is greater than another. Forces are unbalanced when there is movement in any direction, speeding up or slowing down. Slowing down. Conduction and convection. The amount of energy needed to heat a substance depends on how much is being heated, what the substance is made of, what its chemical composition is, and the temperature you want it to be. Particles from warm air bump into particles from cold air and transfer energy to them, increasing their temperature. This process continues until a thermal equilibrium is reached. Heat always travels from a hotter to a colder object. Conduction and convection continued. These are different examples of heat transfer. So, convection is heat transfer through liquids and gases mostly. Particles move around faster when heated. Space between particles increases. Density of the substance decreases. The substance rises. Cooler gas / liquid sinks. And so conduction is heat transfer through solids mostly. So particles when heated vibrate more. Vibrations are passed onto neighbouring particles. Metals are excellent conductors because of lots of free electrons. Evaporation is another type of heat transfer. So a liquid evaporates from a surface due to a flow of air. The particles gain energy, leaving behind a lower average energy, a cooling effect. So infrared radiation or IR radiation is an EM wave that can be transferred through a vacuum, which is another example of heat transfers. So let's look at some energy calculations now. So power equals energy divided by time. Power is being measured in watts, energy in joules, time in seconds. So energy is actually, and then we can just use the work of the energy is power times time, and time is energy divided by power. Right. And obviously, if we want to work out how many kilowatts hour there are, we do energy, which is equal to kilowatts hour, which is measured in kilowatts hour, is equal to power in kilowatts times time in hours. And then we can work out some prices and stuff. So that's there. Light travels in straight lines, flexible surfaces, and white light is made up of several colours: red, orange, yellow, green, indigo and violet in that order. It's called the visible light spectrum. Before red is infrared and after violet is ultraviolet. Light travels at 300 million metres per second, and it takes like 8 minutes to reach Earth from the sun. Okay. Light continued. The light is made up of 3 primary colours: red, green and blue. And their 3 secondary colours: yellow, cyan and magenta. So next is reflection, and so you have to look at the diagrams really, but basically the incident ray hits the surface at the angle of incidence, and a reflected ray bounces off at the angle of reflection. And it's important to note that the angle of reflection is always equal to the angle of incidence. They're always equal. In all cases of reflection, they're equal. Okay. it's got refraction. So basically, light enters a prism, and then because it's going from an area that's of sort of lower density to an area of higher density, it bends towards the normal line. Then when it leaves the prism, it bends away from the normal line. So basically, to summarise that, when light moves from a less dense to a more dense area, when light moves from a less dense to a more dense material, it slows down, bending the light. So it doesn't bend. So absorption and filters. Any coloured object. So any coloured objects reflect the colour that they are. The other colours are absorbed. So for example, if you have a blue object, shine much light on it. Blue's reflected, all the other colours are absorbed. Right? Black objects absorb all colours. White objects reflect all colours, absorb none. Filters subtract colours from light. Right? So they let light of the same colour, like as a wavelength, through while absorbing the rest. So you have some filter diagrams you could have a little look at. So filter diagrams are quite important, but yeah, they're quite basic. Dispersion of light. So, important to note that light travels in waves, and they have different wavelengths, right? So, red, in the visible light spectrum, red has the longest wavelength and violet has the shortest, and obviously radio waves have a really long wavelength and ultraviolet has a much shorter wavelength, etc. And obviously dispersion of light is when an incident ray, so then the dispersion of light continues. This is actually the description of dispersion of light this time, and not just sort of like talking about wavelengths and stuff. So we can use a carbon to So we can use a spectrum to split light into 7 colours. This is called dispersion of light. Dispersion happens because each colour has a different frequency and wavelength. When the incident ray enters the prism, each colour in it is refracted by a different amount. Red light has the longest wavelength and has a low frequency, so it is refracted least towards the normal line. Whereas violet is the opposite, because it has the sort of shortest wavelength. Right. So I was trying to let you to just sort of name 3 types of forces, really, or just 3 sort of forces. Any 3. So this list you can choose from: push, pull, torsion, gravitational, friction, buoyancy, magnetic, air resistance, compression, thrust, up, thrust, and weight. Any of those are fine. Okay, so forces are measured in watt. So there's neutrons and their symbol is N. Weight's a force, and so how do you work out weight? What's the equation for it? The answer is weight equals mass times gravity. Okay. When does friction apply? It applies when 2 surfaces are going past each other in opposite directions. It acts against the direction of travel's movements. What other force is an example of friction, or a type of friction? The answer is air resistance or drag. Okay. Density is how many particles are in a set area. Is an object floating in water less dense or more dense than water? The answer is less dense. And what's the equation for density? The answer is density equals mass divided by volume. Right. So, what is Hooke's law? The answer is the mass placed on the elastic band of spring is in direct proportion with the extension. Right? Okay. What can an object be doing when the forces acting on it are balanced. Well, two things. It could be stationary, moving at a constant speed. When the force actions are unbalanced, what can it be doing? The answer is speeding up or slowing down. Okay, the amount of energy needed to heat a substance depends on what? Three things. The answers are how much is being heated, what the substance is made of, and the temperature you want it to be. Particles from warm air bump into cold air and transfer energy to them, increasing their temperature. This process continues until what is reached? The answer is thermal equilibrium. Heat always flows from what? Hottest to colder objects. Right. Let's get our next page. Okay. So what we're going to do with these is each. So for conduction and convection, we have the sort of steps. I'm going to tell you one step, and you're going to tell me the next sort of step. So, particles move around faster when heated. Starting with convection. Next step is space between particle increases, and then I'll read this next one is density of substance decreases, and then next thing, the answer is it rises, and then the core of gas liquids sinks. So for conduction, I'm going to let you do both of them. So it starts off, think about like vibration and stuff. The answer is particles vibrate more when heated, and the second step is vibrations are passed on to neighbouring particles. A liquid evaporates from a surface due to a flow of air. The particles gain energy, leaving behind a lower what, and then what effect is it? The answer is lower average energy, and it's a cooling effect. Really, cooling effect is the most important sort of part there. I'm not going to do IR radiation because I don't think it's really important. So power equals what? Energy divided by time. And what is power measured in? What is time measured in? What is energy measured in? The answer is power watts, time seconds, energy joules. Okay, we want to work out kilowatts per hour. What is the equation? The answer is energy equals power times time. This is a bit weird, so it's times time. It's a bit weird, but yeah. Light travels in what line? It travels in what? Straight lines. Light reflects off surface. White light is made up of several colours. What are they? And he's saying in the right order. The answer is red, orange, yellow, green, blue, indigo, and violet. And what are these called? What do they make up? The answer is the visible light spectrum. Before red is infrared, and after violet is ultraviolet's fine. Okay. Don't really need to know about that. What are the three primary colours? Red, green, and blue. What are the three secondary colours? Yellow, cyan, and magenta. Right. Any coloured object reflects what? The colour that it is, and all the others are absorbed. Black objects do what? They absorb all colours. White objects do what? They reflect all colours. What do filters do? They reflect colours from light. And they also let light of the same colour wavelength through while absorbing the rest. Right. What is always true about the angle of incidence